Hello everyone. Today I'm gonna to introduce you the Oblique photography technology's docking scheme and its application. And I wanna introduce you from these four aspects. So first, it's some introduction to the oblique photography. So what is oblique photography? It is through the use of the multiple sensors on the same flat platform. Like this picture, there have the 5-lens camera and is currently commonly used, and many sensors simultaneously collect the images from the different angles, such as vertical and the tilt, to obtain more complete and accurate information about the ground objects. And the images captured at the vertical ground angle are called the positive films, which are the group of the image, and the image captured at a certain angle between the lines and the ground are called oblique films, and which are the four groups of the image. And the oblique photography technology is a high-tech developed in the international surveying and the mapping field in recent years, and it overturns the previous limitation that can only be shot from the vertical angle, and by multiple sensors on the same flat platform, and it can also move from a vertical and capture images from the 5 different angles, include 4 types, to quickly restore the real world. And the oblique photography mainly has these following characteristics. It can it can obtain the images from the multiple viewpoints and angles of view, so as to obtain more detailed site information. Second, it has a higher resolution of the same features, and it's an image with multiple resolutions of the same features. And then it could realistic the 3D space scene. The obscuration phenomenon of the oblique image is more prominent. And then the process of making the oblique photography applications, that is one of his industry's chain, is as shown as in this PowerPoint. And the first is the development of the oblique photography area platform, which mainly includes flying platforms such as powered delta wings and the aerial vehicle and so on, and oblique photography cameras. And then there is oblique photography aerial flight. That is, it's responsible for the implementation of the aerial flight to obtain the oblique image data. And then it's data processing of the oblique photography, which mainly includes a fully automatic or manual intervention modeling based on the oblique image, and the large-scale topographic map surveying and mapping. And then there is a 3D GIS platform that supports the result of oblique photographic data, which is GIS basic platform mainly provided by SuperMap. So the we could use the GIS platform to do some analysis or do some display to make applications. So finally, it's based on the application development of the oblique photographic data and the 3D GIS platform. Okay, so this is the SuperMap provides mainly the GIS basic platform. And now, the more popular automatic modeling software for the oblique photography are connected with the GIS platform of the SuperMap. It includes the street factory, context capture, photo scene, and so on. With the help of the oblique photography modeling software, many data formats can be generated, including the OBG, OSGB are in this figure, and DAE and other universal compatible formats. And you could find it in the XML file. So this is a project of the Shuanghe city in China, and it's a project completed in October 2016 and using the drone oblique photography technology. And the flying area is about 20 square kilometers, and the image resolution is set at 4 centimeters. And in this way, the modeling effect is very good, and the accuracy is also high, and it provides a real external environment for the Shuanghe city to plan and design the road and the underground pipeline networks directly on the 3D model in the future. That is the application of the oblique photography. So how to access this photography data? And let's take a look at the second part of today's class, the docking scheme. And this is an already docked partner of the oblique photography modeling software. So each modeling software has its own data format. So how to connect this data format and integrate as a GIS platform? And let's take a look at. So SuperMap GIS provides a convenient and efficient model loading method, and there don't need to go through the process of the data import and format conversion. Only use a configuration file to directly load the original model data with extend name is OSGB. So it could directly load the OSGB file format. And as shown in this image, this figure, the SuperMap at desktop could generate a configuration file and quickly read the model file information through the configuration file. And this model loading the mechanism guarantees the massive capacity of the SuperMap GIS projects for the oblique photography modeling data and the effect of the fast loading and the real-time rendering. Okay, so let's take the exercise of the import of the docking method. That is our exercise. We are gonna to take the oblique photography model of the Mosaic France as an example and practice how to use the SuperMap at desktop to generate the configuration files and quickly read the model files through the configuration files. Okay, and then let's open the SuperMap at desktop. Okay, and let's open the SuperMap at desktop. And let's look at our data first. So I have give you guys a lot of data, and in this exercise 1, we are gonna to use the OSGB Mosaic. And let's open this OSGB Mosaic and open this folder and open its tail. Open this metadata folder, and we could see that is the data that we have convert, and let's express it, and let's compress it as in our file, and let's wait a minute. Okay, and let's open this OSGB Mosaic and open this tail, and we could see there are a lot of the OSGB file. Yeah, so if we import this file to our JS platform, and it's a real big project. So in the SuperMap, it's just concentrate this OSGB file into a configuration file, and we could use this configuration file to read the information from this OSGB file. So how to generate this configuration file? And let's look at it in the 3D data tab. It's in the 3D data tab, and there have the group of the oblique photograph. And let's click this data management and find the generate configuration file. And I will repeat it in the 3D data tab and in the group of the oblique photograph, and click the data in management button and click the generate configuration file. And then it will promote this window, the generate OSGB config file. And then let's find our OSGB path. It is the source data, source path, and let's find it in the OSGB Mosaic. And click this as our source path, and we could specify the root node. So our root node is this tail 008001, so that is automatic to select it. And then if you have the metadata, you could select it. And then let's select the results path and select in this Mosaic 1, and change its name as config file. And then let's input the longitude and the latitude of the missile. And let me look at it's okay, and let me look at it's a 5 and 43. 5 and 43, and we could input its latitude and longitude as a model reference. And for the projection for the coordinate system, and we could see we can set its a projection or import the projection file, or translator its a projection as a project coordinate system, or we could select its ENU coordinate system. So how to set this coordinate system? And let's come back to our PowerPoint, and I will introduce you the detail. And let's look at how to set the coordinate system of the oblique photograph data. So do you remember the ENU coordinate system? So we should confirm our coordinate system of the oblique photography model data. Use the metadata.xml if you have. And for the ENU, so what is the ENU project coordinate system? It is a station center coordinate system, and with the station as the origin. So the 3 coordinates access point to the east, north, and the sky directions to each other. So the station center coordinate system is also called the northeast sky. It means ENU coordinate system, and is generally used as a construction engineering, can also be used to understand the movement laws of other projects centered on the observed. So the station center coordinate system often includes the coordinate system conversion during reuses. So the ENU projection coordinate system function is used to project and transform the oblique photography data whose original coordinate system is the ENU coordinate system to the required target coordinate system. So if your oblique photograph data is a ENU coordinate system, you must to check this checkbox and to generate a configuration file and with a GNU projection. So our spherical scene and the plane scene supports the 1984 coordinate system and the projected coordinate system, and some data may be used the ENU coordinate system. So before we generate the oblique configuration file, and if we want to display the scene successfully, we must to perform the coordinate system conversions. And after we set its ENU, and we should do the functions of the ENU to projection. Because of our spherical scene and the plane scene supports the 1984 and the projected coordinate system. So if the coordinate system of the multi-source data is not uniform, so according to the needs of the project, and we should transfer our projection. So that is our coordinate system. Okay, and let's come back to our SuperMap at desktop. And let's continue to generate the OSGB config file. So for our MyCell data, it's we just to cite its model center, and we maybe not don't set its don't set its coordinate system. And let's click OK. It will promote us. It's recommended at compress the textures. And for this function, and I will introduce you later. So let's click OK. And it's successfully to generate the SCP file. And let's right-click the scene and click the new spherical scene. Right-click the scene and click New Spherical Scene, and find the general layers in the Layer Manager. Find the general layers in the Layer Manager, and right-click it and add the OSGB catch layer. Add the OSGB catch layer, and let's find our config file. In there, config file. And right-click it and zoom to layer. Okay, we can see our we are successfully importing the OSGB file, the oblique photography file. Now we could see its accuracy is high. And we could look at our data in the Mosaic in France. Okay, that's our first exercise to import the oblique photography file. And that is our first import method. Now let's look at our second import method. We can look at this is a configuration file that was quickly generated by the DJI UAV and the company, and the DJI making map company modeling software made in China. And this is a DJI software directly generates the S3M data through the SuperMap's S3M read-write development kit. And then this is our second method to dock the oblique photography model, and then browse and display on the SuperMap JS platform. Now let's look at our second docking method. Currently, this company oblique photography modeling software company through the Open S3M read-write development kit. Through this Open S3M development kit, and directly generate the S3M 3D tail catch data, the S3M format oblique photography data. So the oblique photography modeling software connects to the S3M standard to directly generate the S3M 3D tail catch data. So what is S3M? And let me introduce you in detail. The S3M is the abbreviation of the 3D spatial data standard. The 3D spatial data standard mode. So S3M is We have talked about so many data types, and it's also very important to provide a unified data standard for all 3D data types. Such an open and unified data format means that any 3D data provider and 3D data receiver can support the docking and share the data. And we can import this multi-source data like the BIM, oblique photography, and LiDAR data into the GIS software through a unified data entrance OGDC. And the application developed based on the OGDC standard interface does not depend on any spatial database and data format, and access the spatial database in a unified way, and operate the 3D point, line, polygon, and another data set to achieve the interoperability of the spatial data. So for the S3M, for this multi-source data are uniformly generated and output in the S3M format. So the S3M is suitable for the data transmission and exchange and high performance visualization of the massive. So multi-source 3D geospatial data in the network environments and the offline environments, and as well as meeting different terminals like the mobile, PC, and the web, VR, AR, to browsing the 3D geographic information system related to the application on this terminal. And then we provide the free S3M data file reading and writing software development kit, and provides the development tool and the simple data and the documentation. We also provide the free data formats conversation tools, include the conversation tool for oblique photography model, includes OSGB and OBG, and the conversation tool for the 3D tiles to the S3M. And you could scan this QR code to obtain this tool. Okay, and let's look at the oblique photography data. Is automatically generated from the area survey data, and the triangular grid is compressed and it's refined, so the resulting in the relatively large amount of the oblique photography data, which brings severe challenges to the data conversion and its loading and application performance. And one of the key points for the independent industrial application of the oblique photography model is whether it can provide a stable and a smooth browsing performance. So how can we process and optimize the data? Let's look our third part, the processing and optimization. And for the processing and optimization, we have this three parts to do. So our first part is effect repair. So what is effect repair? As a new technology in recent years, the oblique photography technology has some flaws in its data, and such as model health and the poor modeling of the small-scale features and the mismatch with the terrain. So, in the oblique photography, before the technology improves, in order to achieve the good application effect, some repairs functions need to be done at this time. And the repair includes the operation of the repair includes the clip, mosaic, and texture replace. So first, let me introduce you the clip. The oblique photograph data cropping. A clip release the customer clip of the oblique photography data. So you could select a polygon or drawing a polygon as a clip area, and this method is convenient for you to obtain the oblique photography data within a specific range according to their needs. So this method is also suitable for the model map catching. And the oblique photography model clip operations refers to obtain the oblique photography data within a specific range according to the user's needs. And the clip function will have occupies a large amount of memory, and it is recommended to use a 64-bit desktop version. Okay, and then let's do our second exercise. Our exercise is to take the oblique photography model of the Marseille, France as an example and practice how to use the SuperMap at desktops to clip the data. And we will use the OSGB Mosaic workspace. So let's come back to the SuperMap at desktop. And let's click the tab of the 3D designer. Click the tab of the 3D designer and find in the OSGB processing and click this clip button to clip the oblique photograph data. And let's select one building and let's select this building and click the clip, and it will promote this OSGB data clip. And let's click this draw react angle. Click this draw a react angle, and let's draw this clip. Okay, let's look at when we click this draw the one region, and it will to clip this one region. So let's re-click it. That is not very good. So let's look at this. And in this step, let's draw a polygon. Let's draw a polygon to click a point, to add a point to draw a polygon, and right click to finished, and click the preview. We could see that is data that we have clipped. And we can click this clipping tab to select the internal and external. So that is within the clipped area and outside the clipped area. So when we select the outside the clip area, and it will clip the oblique photographic data and remain the outside the area. So this is not real. Let's to reclip this area again, and we can see we have clicked this area, and then we could also import this data to the file by click this result data group, or we could click this to export this region, or you can do something in this data clip. So we can use this method to click some areas. For example, some buildings are about to be demolished, and we can crop this in a desktop first and see this the effect that demolished this. Okay, and let's come back to the PowerPoint. Okay, and then let's come back to the PowerPoint. Next, let me introduce you the Mosaic. In this Mosaic, we use the BIM data to mosaic the oblique photograph data to achieve the purpose of the modifying the oblique photography data. For example, in this video, let's look at this video. The bottom surface extract from the BIM model, and it's with the inclined model. So that's the inclined model, and the BIM data can achieve the better fusion effect. And BIM data and the oblique photography data models usually use a different coordinate system. So before we mosaic and matching and coordinate system conversion, you should perform it first. And in the SuperMap at desktop, we could not only support the coordinate conversion function of the model data, but also the registration function of this model data. So we can facilitate the automatic matching of the BIM model in the engineering coordinate system to the specific coordinate system. At this time, the inclined photographic model in the area where the BIM model is located needs to be inside and flattened. And the slope protection parameters can also be set to achieve the smooth and transition at the data connection. So that is a mosaic operation. You can find it also in the 3D designer, and there have the mosaic, and there have the mosaic function. Okay, and then there also has a function named texture replace. The oblique photography technique is not very effective in the modeling and the small scale features such as street lights and these cars, and these features often appear maybe broken, suspended, and protruding in the oblique model. In order to solve this problem, and SuperMap GS software provides this practical flattening function, this texture replace function of the oblique photographic model. So the resolution of this process is very simple. You only need to draw a polygon in this area, and you want to replace and perform the and editing when you're drawing to adjust this texture, this polygon range to ensure that the accuracy of the flattened polygons and the oblique photographic data located in this polygon area and only into a plane, and finally the 3D model symbol. You could place it on the area to complete the optimization of the small scale features effect. You could select the color to replace it. So let's do this exercise 3 to take the oblique photography model of Marseille, France as an example, and to practice how to use this to texture replace this data. Okay, let's do it. Okay, let's click the 3D Designer button, and there have the texture replace in this OSGB processing. And let's find a road and a car. Let's look at in this road there have some small scales the car, and let's select this car and click the texture replace. Okay, and then let's do the draw a polygon like this, like our last exercise. Click the draw polygon and draw these cars. Right click to finish it, and then we can select the color. We could use this pick color button to select this color of this road. So we have replaced this car's bad texture it. So if you wanted to modify this small scale features, you can use this function to do it. That is our exercise 3, and let's look back the next. It's a straight tree repair. So the oblique photography technique is not very effective in the modeling small scale objects that we have introduced you, so such as the cars or these street lamps and street trees. So these objects often show the broken, suspended, and protecting phenomena in the oblique model. In order to solve this problem, a desktop provides the model flattening function to incline the photographic model, which can remove the broken and suspended part of the oblique photography model, and then we could place the 3D model symbol in the original position to replace it. So this process is very simple. in there, you could only draw a polygon in this area, and you wanted to replace and to editing when to adjust the flattening range and to ensure the accuracy of the flattened polygon, which is located in this polygon, and the oblique photographic data in this area is flattened into a plane. And finally, you could use this 3D model symbol like this tree symbol, tree 3D point symbol to replace on the area to complete this optimization, the small scale feature effect. Okay, that is straight tree repair. And then let's look at the terrain repair. The oblique photography model is a digital surface model that contains real terrain information, and in the practical applications, it's often necessary to import the oblique photography model into a scene that already has the terrain information. But in order to the acquisition time of the oblique photography model and the original terrain and the inconsistency of the collection accuracy results in the mismatch of the top photography of these two types of the data, such as insertion of the original topography into the oblique photographic model. And in order to solve this kind of problem, you can replace or modify the original terrain data to achieve the goal. But you can only find another way when you lack the data modification authority or the ability. For this reason, SuperMap GIS at desktop provides a method to modify the terrain that displays the level without changing the real data. So this method solves the problem of the interest in inserting the terrain into the oblique photography model by processing the original terrain in the specific area under the oblique photography model, without affecting the oblique photographic display of the this model area. So you could use this terrain repair, the terrain mosaic that I have introduced to you, to draw a polygon to solve this problem. Okay, and then let's look at the water effect repair. In oblique photography model, some pores often appear in the water surface. There will have some holes area. So that's maybe in order to that may be because of the lack of the data. So SuperMap at desktop can restore the water surface effect of the water of this oblique photography model through the filling symbol of the water surface, and it provides a variety of the water surface effect parameters, such as this a reflection and clamp and so on. So we could to fill the surface of the water and to use water symbols to affect this water. Okay, that is our water effect repair. Okay, and then let's look at how to how to optimization the oblique photographic data. Okay, and let's look at how to optimization the data. After the so that is a result that optimization. After the optimization, and this full frame loading can be realized instantly with a high frame rate and low memory usage. And the oblique photographic data is automatically generated from the oblique survey data. And the triangular grid is fine and complex, resulting in a relatively large amount of the oblique photographic data, which brings severe challenges to the data conversion and the loading and application performance. One of the key points for the in-depth industry application of the oblique photography model is whether it can provide a stable and smooth browsing performance. And SuperMap provides some key technologies for the oblique photography data to realize efficient loading and the smooth display of the TB level oblique photography modeling data. We can see this video. It could display this very smooth and the big large scales, the big large data, oblique photography modeling data. Okay, so and at the same time, it also supports the long-term operation, high stability, and the low hardware resource usage. And it also can using this data range, data texture, and the terminal tab and the data interaction. So how to optimization the oblique photographic data? We have this function, includes a merge root node and the compress the texture and generate the S3M data file and the distributed management solution. So let's look at this respectively. First is a merge root node. This function is in the 3D data oblique photography and in the data processing, and there has the function of the merge root nodes. You can find it in your SuperMap at desktop. And in the data production process, due to the insufficient software or the hardware resource, includes a software license or the hardware memory, it needs to be divided into small blocks to generate the OSGB model. So if the set length of the block is too small, it will cause the thousands of the fields under the one measurement area. In order to improve the model loading and the browsing performance, a SuperMap provides a root node merging tool, and for adjacent small blocks are merged into a new large block. So you could select the level to set the member of the merge to reduce the number of the root nodes until the performance, and that is more optimal. Okay, that is a merge root node. And then let's look at the texture compression. SuperMap provides a compression tool that can compress the texture data in the oblique photograph data and in the texture compression format. And the compressed texture is packaged into the OSGB model file. And finally, the OSGB file is a ZIP compressed to ensure the compression. And after the data is small enough, the compressed file format is still the model file of the OSGB. Through the data compression, the texture data and the models can be downloaded and loaded into memory at one time. And the texture can be loaded directly into video memory without the decompression, so that the model can be loaded more quickly while reducing the memory usage, which can improve the model data. And the load capacity also improves the overall performance experience. Okay, and it will generate the S3M or S3MB file. It performs the texture compression and the ID unitization operations, and that function I will introduce you later. And it's on the original OSGB format of Oblique photography model data and convert it to the OSGB data by the .scp file into the corresponding S3M or S3MB data. Okay, and let us look at all the files that we have compressed it. And let me open this file, this folder, and in the OSGB map cell, that is, I have to compress it. We could see there out of this file are the .s3m file. So that's we have compressed it. Okay, and then we have verified and tested the distributed processing stream of the Oblique photographic data. We store the 292 GB of original Oblique photography data in the distributed file system, HDFS system, and then distributed it and calculation, and the result data S3M are generated and stored in the distributed database like the MongoDB or the HBase database, and then published it as a service, and the final result is very good. So that is a precise of the Oblique photography data. Okay, then let's look at the model segmentation. So what is segmentation? What is singulation, and why we singulate it, and how to singulate it? So let's look at the concept of the singulation. And the Oblique photographic data was constructed based on the surface model, and which failed to realize the singulation and the objectification of the surface objects. So we wanted to put it simply, and the entire area in the Oblique photography data is an undulating continuous scheme. So the surface objects in the data, such as houses and trees, are part of the entire data, just like the small area on the large piece of the cloth. So similarly, it cannot be operated and managed separately because it can't be operated individually and object-oriented, which makes it difficult for the oblique photographic data to link attribute data, and it is difficult to connect with the business management system, and resulting in the oblique photographic data. And the unmanageable situation makes it difficult for the value of the oblique photographic data to be fully utilized, and it has been called a vast application for many years. So, how to realize the singulation of oblique photographic model and support the GIS operations such as the building selection or the attribute query or the spatial query, and the production of the semantic maps has become a hot topic in the 3D GIS research and the And now there have the three methods for the singulation of the oblique photography, and that is cut singulation, ID singulation, and dynamic singulation. So the cut singulation is to cut the slice into individual buildings, but the cut out 3D model will have the topological errors and can be spaced and searched and calculated and analyzed. And the ID singulation refers to the combining and the exciting 2D vector surface data and assigning the ID value of the corresponding vector surface as an attribute to each vertex in the triangulation of the oblique photographic data. And then the vertex of the triangulation corresponding to the same features is stored the same ID value when the certain triangle is selected by the mouse, and other triangles with the same ID are obtained according to the ID value of the vertices of the triangle, and the other triangles with the same ID are the highlighted, and the effect of the individually selecting and a certain feature is realized. And the dynamic singulation that we often use the singulation. So, what is dynamic singulation? That doesn't require the pre-processing of the oblique photographic model data, and the singulation is achieved by the superimposing the corresponding 2D vector plane and load the match 2D vector surface and the oblique photographic model into the same scene, and pass the vector surface to the surface of the oblique photographic objects when rendering the model data, and then set the color and the transparency of the vector surface so as to achieve the effect of the individually selecting features. And this method can make full use of the spatial query and spatial computing capabilities of the vector areas data model, and supports more powerful 2D and 3D integrated GIS application. So we also use the dynamic singulation. And in the process of the dynamic singulation, how to quickly obtain the vector plane of the oblique photographic data. The SuperMap uses a deep learning model constructed based on the CNN based unit network structure to automatically extract the underside of the building in the oblique photographic data to optimize the process of the individualization of the oblique photographic data. So first, the DOM and DSM are extracted through the oblique photographic data, and the model automatically extracts the underside of the building through the image information of DOM and elevation information of the DSM to generate the vector data. And the extraction result can be superimposed and stretched with oblique photographic data in the 3D scene, and the effect is shown in this figure below. So let's look at the process of the how to building the hierarchical household management. So first, we could have the OSGB file and generate the configuration file, and connect to the 3D scene, and then generate the DSM data set and the vectorize the polygon data set. So this is our vectorized polygon data set. We based on this many of the buildings and to digital this vector data, and then click the polygon according to the house tab and copy this polygon according to the floor. So if you want to add multiple floors, and you should overlay this vector polygon data. So you could copy this polygon according to the floor. If you have the 3 floors, you should copy the 3 polygon, and then enter the bottom elevation and height and house number and homeowner and other attribute information of each house, and then batch and stretch vector face and save the scene and workspace. And then let's look at there has the vector data that we have done, and let's look at it in the desktop. Okay, let's come back to the desktop, and in this vector data source that has the vector R data set, and let's drag it to our window, and we could see that it's under the model, and let's click the style settings to make it up the model to its extension settings, and select the collapse to the object, and it will collapse to this object. Like in this, it will collapse to this buildings. And then let's modify the select. We could select these vectors and click properties. It will appear that it's a year and its height in our vector data. So that's a vector that we have done it, and we do the singulation and to make it and add the field as attribute of our vector. So that is our singulation. That is the building hierarchical household management. And then there have another JS application based on the singulation. And first, that is the map check attributes. We could use it to query the attributes, and then to query the map, and to make the buffer to query it, like to query in 1 kilometers. Does we have the supermarket or something? Or we could also make a semantic map in the Oblique photography model to use this singulation options. And there also have the JS application based on the utilization. It could apply in the real estate certification, and we have the certification picture, and we could overlay of each floor and household map, and to stretch it, and it's as a 3D model, and to texture it as a 3D texture. And then we could query for each floor and the household map, and we could query some information of each floor or each room. It could apply in the real estate and the property satisfied household inquiry. And this is a natural resource and real estate registration information management platform. We could use it in this platform to do some query each floor and some another operations. Okay, and then let's look at our last part of the application of the oblique photograph. SuperMap desktop supports the efficiency loading of the massive oblique model data, and it easily realizes a single operation and expression, and provides a smooth 3D experience, and meeting the needs of the application in the tourism, science sports, real estate, land, or urban management, smart cities, and other industries. Especially in emergency operation and timely and rapid data precision capabilities, and the decision-making analysis play a decisive role in ensuring the safety of the personnel and the properties. So it's the oblique photography model data is widely used in the field of the land resources management or something, and we could use it to application in the so many industries. And that is simulate the oblique photography to simulate the effect of the demolition of the buildings, and it can be replaced with a refined model to achieve the comparison and display of the planning stream effects. And that is surface excavation and check underground pipe network. We could use it to do this underground pipe network view. And the oblique photography model also has elevation information and texture. It can extract the height precision, the DSM and DOM, and the 2.D image, and can produce data based on the generated data, such as exacting, building, vector, ground, and so on. And the 3D points of each analysis point can export, and the result of the shadow ratio analysis can also be exported. So we could use oblique photographic model data to do this shadow analysis. And to do this urban flooding simulation, use oblique photography model data. We could see that is a simulation of the flooding. And this is an interface for the operation of the 3D real estate information platform. If we click on any building, unit, or even any small house, and the corresponding attributes in this in the database will be displayed in this small window. That is a real estate platform, and it could also be applied in the 3D printing. We could use the oblique photography model and terrain data model, terrain data, and then we could select the terrain and to clip the area and to build a 3D solid model and convert it to the STL format and use this equipment to do the 3D printing, and it will export this solid model as a 3D printing results. And the full range of the SuperMap JS products supports the oblique photography models, including the server, desktop, component, web, and mobile. So the cross-terminal advantage brings a broader and diversified development potential for the application of the oblique photography models in the JS. And oblique photography model data is also good to use in the WebGL. And it's usually a lot of files, which is cumbersome to copy, share, and deploy, and it's difficult to encrypt data. And it supports to storing data in the MongoDB and can be deployed in the cloud of the easily publish the service in the WebGL client. And the oblique photography model has a large amount of the data and a large number of the files and high security requirements. And this storage model brings users a more consistent and safe data management experience. And it's realized that the entire system of the product supports the oblique photography data from JS servers to the desktop. And it could also to be applied in the plugin client. Okay, that's our oblique photography course. Okay, thank you everyone. Thank you guys.